Okay, let's go find that mistake. See, and like I said, real reason why I don't redo the videos when I make mistakes is because I'm lazy, but I could also say that the real reason I don't redo the videos when I make a mistake is because that gives you the more real life class experience. If you were in a classroom, I still would have made that mistake. Here's the mistake. I said, oh, we're going to distribute 2 times x squared, 2x squared, 2 times negative 3 is not negative 3, is negative 6. So there's the mistake. And we will fix that. And so this is supposed to be negative 6 here. And then I'm going to subtract 2 from both sides. And so then this is going to be negative 8. And negative 8. And then, still the same thing, factor or quadratic formula. And if you're not good at factoring, use the quadratic formula. But if you're better at factoring, like me, who's been, I'm really quite old. I would say how old I am, but if I say that this year, if someone watches them next year, it won't be true anymore. So I'll just say I'm old. It's good enough. I can factor because I've been factoring for a really long time. First terms must multiply to be 2x squared, so 2x and x. Last terms must multiply to be negative 8, but I have to create that negative 15x in the middle. And what's going to work is plus 1 minus 8. 1 times negative 8 is going to be negative 8. And then just checking that factoring in the middle, I'm going to get negative 16x plus 1x for negative 15x, and that checks the factoring. But now it's factored and equal to 0. And because it's factored and equal to 0, I can split this up and get 2 answers of negative 1/2 and 8. And so there's that last problem. And you could check this the same way that we've checked the others. You could check them by plugging them in or doing the graph. But again, on these exponential equations, checking is optional. If you did your work correctly, the answer will be correct. But, come test time, and in the future, if there are quizzes, you've got a few moments and you have time to check these things. You might find a silly little mistake, I made a little silly mistake the first time around. You might find a little silly mistake and save yourself some points that way. Okay, so this was the first method for exponential equations. Being able to do this step right here of making those bases match. That isn't always going to be possible. So when it's not possible, we need another method. And that brings us to what I have labeled method 2. And remember, that's just my personal labeling. It's not mathematical labeling, just my personal labeling. So method 2, let's go in a little bit. So the above method only works if it's possible to express both sides of the equation with the same base. When it's not possible, we'll have to use a different method. We will have to use natural logarithms to solve the exponential equation. Now, I've just gone with natural logs here. In reality, you could use whatever logarithm you wanted. Common logs, base 10, log base 3, log base 4. We're just going for natural logs just because that's what most people do. But you can use whatever logarithm you want, really. We're just going to go with natural logs. Using natural logs to solve exponential equations. 1, isolate the exponential expression. 2, take the natural log of both sides. 3, simplify the logarithm using either natural log of b to the x equals x log natural log of b, or natural log of e to the x equals x. This first one is just the power rule of logs, that exponent can come down in front. The second one, you just got to learn that natural logs and natural exponentials, natural logs and e to the x, those are inverse operations and they quote unquote cancel. 4, solve for the variable in terms of natural logs. 5, find a decimal approximation if required. 6, check. And again, checking, a nice thing to do here, but not required. So solve the following. Express the solution in terms of a natural logarithms or common logarithms. Then use a calculator to obtain a decimal approximation for the solution. So I just took those instructions directly from my lab math. They give you an option of either natural logs or common logs. I'm just going to do natural logs because if you go into calculus, everything in calculus is natural logs. So we're going to go ahead with the natural logs. So first of all, how I'm going to notice that it has to be this method. My base here of my exponential is e. There is no way that I'm writing the rest of the problem in terms of e. I cannot do what I did over here, which is write 25 and 125 both in terms of 5. Can't do that. I cannot begin to write 60 in terms of e. So I will use this method of logarithms. So first thing I'm going to do is divide both sides by that 6 to get that exponential alone. You want to get the exponential alone. So get e to the 7x alone. Then once I have that exponential alone, I take the natural log of both sides. That's really the magic key step here. Because natural logs and e's, those are inverse operations, and so I just get 7x. And now we're just going to solve for x. So divide both sides by 7, and I get 7 equals natural log of 10 over 7. And that is the answer. And that bothers students. They don't want that to be the answer. They want the answer to be 12 or something like that. But remember, logarithms, really, when there's not a variable involved, natural log of 10, that is just a number. Now, it's a specific number. It's a number that happens to represent some sort of weird exponent, but it is still just a number. So this guy right here is a number. So there is the answer in terms of natural logs. And then as far as a decimal approximation, you just take your calculator out and you figure out what that is. Natural log of 10 divided by 7. And that's approximately equal to 0.3289. And there we did it. And then you could check this the exact same way we've checked the others. You could check it by hand or check it on the calculator, but it should check. And we'll actually check it by hand really quick because I got enough space. Check. 6. So we've got 6 e to the 7x, wondering if that's 60. So 6 e to the 7 times 0. I'll put an asterisk there for times. 7 times 0.3289. Just do that on a calculator. Let's do that on a calculator, see what we get. 6 times e. Remember how to get e in an exponent? Second natural log gave me that e, so let's do that again. 6 second natural log gives me the e in the exponent. Then I want 7 times 0.3289 in the parenthesis, in another parenthesis, then hit enter. And it looks close. And it's only going to be close. So I'll put a little squiggly equal marks here. 59.98. And because we rounded my answer, this is only going to be close, and so it checks. And like I said, the checking here is optional, but if you've got a few moments, check it, because you might catch a mistake. You can also check it graphically like we've done in the past. Okay, one more, and then we'll go on to logarithm equations. Let's bring that back down for a little bit. Okay, so there's that one. Step number 1 was to get that logarithm alone. So or not the logarithm, get the exponential alone. Okay, next problem. Again, get the exponential alone. So I've got to get the 7 2x minus 4 alone first. And got to get that guy alone first. So let's add the 6 to both sides. And so I get 7 to the 2x minus 4 equals 48. And then I look at it, and I ask myself whether I could match the bases. Can't. If it was 49, I could match those bases. But it's 48, and I can't say 48 is 7 to some sort of nice exponent. Yeah, there's some sort of irrational, weird exponent to make it work. But I can't say right off the bat 48 is 7 to the whatever. So I have to use logarithms. I can't match the bases. So use natural logs. So I'm going to take the natural log of both sides. And then I'm going to recall that natural log of b to the x is x natural log of b. That my power rule for logarithms, that exponent can come down in front. Now, careful use of parentheses comes down in front. And now I have to solve for x. There's more than one way to do this. But to me, the easiest way I see here is to divide both sides by that natural log of 7. So divide both sides by that natural log of 7. And so then I have 2x minus 4 equals natural log of 48 over natural log of 7. That in no way, shape, or form simplifies. That's that. But I still have to get the x alone. So let's go up here and finish. Then I could move the 4 to the other side. So then I have 4 plus the natural log of 48, or 4 plus the natural log of 48 divided by the natural log of 7. And then I have to get that 2 alone. And probably the easiest thing here to do, or get the x alone, I have to get rid of that 2, is to multiply both sides by 1/2. And so I get 1/2, or I get x equals 1/2 times 4 plus the natural log of 48 over the natural log of 7. And that's perfectly fine. Come test time, just get me a correct answer over here. I am not going to fuss exactly how should that correct answer look. You could leave it like that. If you wanted to, you could distribute that 1/2. So then I would have 2 plus the natural log of 48 over 2 natural log of 7. There's a perfectly good answer. You can make that answer look like anything you want, as long as it's correct. And then if I need a decimal, let's do this last one here. 2 plus natural log of 48 in the parentheses, divided by, then put that entire denominator in parentheses, 2 natural log of 7. In the parentheses for the natural log, in the parentheses for the denominator. And so my decimal approximation is about 2.9947. 2.9947. But again, what I'm going to be mostly concerned with is this work being correct, and then how you choose to do this part down here where we solve for x. There are multiple ways to do it. Just get me a correct answer. And then this would check the same way as the other guys. And we're in this video and go to log equations on the next video.